Hello guys, welcome to my YouTube channel. My name is John Ken and Sam. In today's video, I'm gonna talk about radicals, chemical formula, balancing equations, writing chemical formulas and equations. Let's start with radicals. The first question is that what are radicals or what is a radical? You can say a radical is a group of atoms which is present in several compounds but incapable of independent existence. It is incapable of independent existence. It does not exist on its own. No? Then there are some radicals which have the valence of 1, 2, 3. Let me give you examples of radicals with valence of 1. Ammonia, then chlorate, chlorate, chloride, hydrogen carbonate, hydrogen sulfate, hydroxide, nitrate, and nitrate. All of these, they have the valence of 1. Their valence is 1. Then those with a valence of 2, um, carbonate, oxide, sulfate, sulfate, and sulfite. These they have a valence of 2. Then those with valence of 3, we just have phosphate. Phosphate has a valence of 3. So these are radicals. Okay, let's move on to chemical formula. A chemical formula consists of a symbol or symbols showing the number of atoms in one molecule. So there are some steps which you must follow when writing a chemical formula, or you must consider. Number one, the first one, you need to write the symbol for the combining element and radicals. Then the second one, write the valence of each element or radical at its top right-hand side. Yeah? Then the third one, exchange the valences of the combining elements and radicals by writing them at the bottom right-hand side of the element or radical. If the number is 1, do not write it. In some formulas, radicals are written in brackets followed by a small subscript digit. Let me give you an example. Let's write the formula for sodium chloride. Sodium chloride, yeah? The formula for sodium chloride. Sodium is in group 1 on the periodic table. Group 1, yeah. The symbol for sodium is Na, and it's in group 1. Huh? We know that elements in group 1, they have the valence of 1. So we write its valence. Then chloride, we said that it's a radical, huh? Chloride. Yeah, it has a valence of 1 as well. Cl with 1. Then you exchange these two. So when we exchange, it's one and the same, huh? It's just going to be like this. Sodium chloride. So this is the formula for the chemical formula for sodium chloride. What about potassium carbonate? Potassium carbonate. Potassium symbol is K. It's in group 1. The valence is 1. Then carbonate, it's C CO3. Carbonate is a radical and has a valence of 2. So you exchange these two. So it's going to be like this. Potassium, this one will be here. Then carbonate. If you don't want to exchange, you can just write down potassium has a valence of 1. Carbonate, valence of 2. You cross multiply. K times 2 will be K2. CO3 times 1, it will be CO3. So this is the formula for potassium carbonate. What about ammonium carbonate? The formula for ammonium carbonate. We said that the formula for ammonium is NH4. That's the formula for ammonia. Sorry for that. Sorry for that. Some technical error. Okay. Yeah, we said that ammonium has a valence of 1. Has a valence of 1. Then carbonate has a valence of 2. So we exchange these. Since this 2 is going to multiply nitrogen and hydrogen, so we are going to write it in brackets. It will be NH4. Then the 2 comes carbonate. So that's ammonium carbonate. That's how you write it. If you don't want to exchange, you can just multiply. Okay, let's move on to something now. Okay. We can move on to yeah, we can move on to state symbols or equations. Okay, let me talk about state symbols a bit. So state symbols are letters that are used to show the physical state of substances in the equation. State symbols are placed in a bracket after the name or formula of each substance in the equation. Let me give you some examples. Physical state and state symbols. So here it's physical. Physical state. Physical state and symbol. State symbol. When something has a gas, gas, the state symbol is G. Liquid, write it like this, is air. Solid, then aqueous. This is aqueous. State symbol to be AQ. AQ. Okay. Um, equations. Equations. What is an equation in chemistry? An equation is a chemical sentence which describes what is happening in a chemical reaction. So, an equation can be presented in the form of, for example, let's say A plus B. Forms C plus D. Here we have reactants and products. A plus B, this one indicates that these two reacted to produce or to form C and D. C and D. That's how a chemical equation is. Okay, what about wedge equation? Wedge equation. These are just chemical equations written in wedge. Example, let me say magnesium metal react with oxygen gas to form magnesium oxide. So here we have magnesium metal react with oxygen gas to form magnesium oxide. We write it in Wade equation. So we say magnesium, magnesium metal, state symbol, solid, reacts with oxygen gas. So plus oxygen gas, then to form magnesium oxide. Form magnesium oxide. Um, Sorry, that's how you write Wade equation. Then you can try this in your free time. Try to write Hydrogen sulfate gas reacts with oxygen gas to form sulfur and water. Yeah, try it out. Let's move on to balancing equations. Balancing equations. Okay, before we go that, all right. Um, Balancing the equation is a process of making the number of each type atom equal on both sides of 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 the equations. That's that's balancing equation. Okay, let me write some examples of equation which we must balance. And let me say that we have mercury, mercury oxide, decomposes into mercury plus oxygen. So this is liquid. Then we know that oxygen is gas. Let's write it in a chemical equation and we balance it. So the formula for mercury is Hg, no? Then this mercury, we have mercury oxide. So it's HgO. Oxygen has a valence of, if you check on the periodic table, oxygen has a valence of 2 and mercury has a valence of 2. So it's going to be like this. Mercury has a valence of 2, oxygen has a valence of 2. So we said that we cross multiply. So, but if you have the same thing, you can just you can cancel. If you have same things, same number, or same valences, you can just cancel them. Then it will be mercury oxide. All right. So here we have mercury oxide, which is a solid. Mercury oxide decomposes into mercury, liquid mercury, and oxygen gas. This is the equation. Now we need to balance it. Okay, so here we have 2 oxygen, there one. Then in order for this equation to balance, what are we going to do? We can add the 2 here. If we add 2 there, the oxygen has become 2, mercury 2, but here we have 1. So we add the 2 here as well. Then the equation has been balanced. So that's how you balance equation. Another example, hydrogen. Hydrogen, hydrogen gas plus oxygen. plus oxygen gas is going to form what? It's water. It's H2O, water, liquid. Let's write it in chemical equation. So hydrogen gas is H. Hydrogen gas is H2O plus oxygen is also O2. They are both gases. Then they are going to produce what? H2O, liquid. Now the question is this equation balanced? Here we have two hydrogen, two, two oxygen, two oxygen here, one. So the equation is not balanced. We need to balance it. So what are we going to do in order for this equation to balance? Here we will need to have two oxygen as well. So we're going to add the two here. When we add the two here, it's going to affect the hydrogen. So here we have 4 hydrogen, 2 times 2 is 4. Then even here we are supposed to have 4. So we'll add a 2 there as well. Then the equation is balanced. So that's how you balance a chemical equation. Okay, the last one. See, let me say we have sodium. This is sodium. It's solid. Sodium plus water. It's going to form sodium hydroxide. It's going to form sodium hydroxide plus hydrogen gas. Sodium hydroxide is aqueous, it's aqueous plus hydrogen gas. So in a chemical equation, sodium is Na, the solid, plus what? H2O. Then it's going to form sodium hydroxide and hydrogen gas, aqueous to liquid, and hydrogen gas. Now we can you can just check if this equation is balanced. Yeah, it's not balanced. So how are we going to balance it? Here we have one sodium, this side one, okay. Oxygen one, this side we have one. Hydrogen, hydrogen we have, here we have three, here we have two. So in order for this equation to balance, we're going to add a 2 here. a 2 there, and here a 2. Then since these two are affected, the sodium is in that part 2. So sodium, we have 2. And here sodium is 2. Hydrogen, we have 2 times 2 is 4. This side 2 times 2, sorry, 2. This one is 2 times 1 is 2 plus 2, 4. Oxygen, we have 2. And here 2. 2 times 1 is 2. Yeah. So the equation is a balance. That's it for balancing chemical equations. Okay, guys, that's it for this video. Please don't forget to subscribe and hit the like button and leave a comment if you like the video, even if you haven't, just say something so that we're improving some areas. Thank you.